If this works, I'll be surprised, but we'll try. Let's see if it comes up. Ha! Oh, it isn't available anymore. Wait a minute. Okay. Give me another second. Okay, here it is. I must have copied it in wrong. Okay. All right. I'm gonna go ahead and share again here in a second here. Go away. Okay, wait a minute. So I'm going to stop it here. Oh, shoot. Let me get it back a little bit. Oh, I'll let it go. Okay. Does this look familiar, guys?
Yep.
Yeah, I'm sure every one of you has got one of these guys sitting in your parts box somewhere. You know, they're so cheap. You get 10 modules for a couple of bucks, and they work. They seem to work. And you know, he mentions that, well, this part, if it were real, costs about 3 times what the module cost. So that's, you know, suspicious. And I will not ruin the whole thing for you, but let's see if I can get it here. What he finds out, it's a fake chip, and he finds this out because it's running at a third of the frequency that it's supposed to. Okay, the chopper, it's about 50 kilohertz instead of 1.5, 1500 kilohertz or something. So anyway, and when he gets all done with it, and this is, okay, you know, he says the efficiency is not there. There's a lot, you know, but it works. You know what I mean? You know, if you do the right thing. If you try to put full current, pull the full whatever it's rated for, 5 amps or whatever, you get what he calls the magic smoke comes out. So let's see here. Okay, so I think this is where I wanted to pick it up. So
either a clone or rejected parts that were still bought as they were.
I'm sorry.
It's the old adage is true. You get what you pay for.
Wow. Wow. Okay. All right. So anyway, like I said, I think that's something that we've all have in our work box, and I thought that might be something you guys might like to see. I'll put the link to that video in the chat. And see, there, I have one more item I wanted to discuss with you guys, but I can't think of what it is. So if I remember, I'll come back in. But anyway, I'm ready to hand it off to the next person. Who said they were going to go next? Was it you?
I did. And I've got two items, but one's kind of just for fun. And I don't know if Carl might have showed this at the last meeting. I wasn't able to be at the last meeting, week of Thanksgiving. The video I put together of Mobot's run at Roborama. I guess you didn't show it.
I haven't had a chance to post those up there yet, so
Okay.
only the ones that Doug took are on the YouTube channel.
I thought I'd share that because I edited it down to 2.5 minutes. That's kind of fun. So why don't I do that? And I've got another topic on Docker, Ross and Docker. But let me, which I can go after, someone else. Then Tom was coming after me. Let's see. Where are we? Facebook. Yep. Okay. Are you all seeing this video?
Yes.
Yeah.
Robot Run 3 started? Okay.
It's lagging a bit.
Paper mode.
I have to change the news output today. It was just such a brilliant day. I thought, got to celebrate it. But if I would have had more time, I would have put some middle.
Yeah, when you consider this was November, November 18th, and everybody look at the short sleeves.
One float from dairy up to a meter.
Okay.
Oh, baby.
Can do it?
Oh, I love you. Yay! I didn't even know it. Oh, you did.
Oh.
Oh, no. Can't get to the next one.
I heard it say please reboot or something. It gave some text.
I don't think it's going to stay.
Robot trying to create a robot cone hybrid.
Turn it off. Okay. Well, that was that.
Cool. I'd like to get, eventually I'm going to put up all the rest of them when Carl gets them available to me, so that, and, even ones that didn't work, where people didn't get any points, there's lessons learned in there if you really watch the robot and what's going on. Like in this one, obviously there was no bumper, but that's Paul said up front, that's the way he was just going to use RTK. So, and,
well, I just want to give a shout out to Doug and Carl for organizing the Roborama. It was such a great event, and you guys did all the work, and I really appreciate it.
Well, really who we should be thanking is Steve for allowing us to paint on his grass and, wander all over it for a day.
Yeah.
So,
Paul, you may be interested in a gentleman named Bob Cook from the Vancouver Robotics Club gave a presentation on Sunday on the process he followed to do machine learning of video signals for his robot that he entered into the Robo Magellan contest at the Seattle Robotics Society last month. Excellent presentation, but you'll be very interested that his biggest frustration is, despite all the effort he put into machine language training and implementation, his robot would keep just missing the cones. It would just drive 6 inches away from them. Drive 100 meters and miss by 6 inches.
Yeah. So, I'm hoping that with a little luck, maybe we can get a group to go up to Seattle and talk to Donna and see if we can run a couple. But, it's...
Bob would welcome the competition. He won both first place and last place.
Yeah.
He was the only entry.
Yeah, that's tough. We all know how hard it is to build those robots. I mean, it is. And so, I'm definitely going to have something next year. I've started now. Not going to wait until the last month. Go. Like I said, I'm thinking LiDARs, If I can just get these, like I say, if I can get on the, I don't really want to go to sub-processors to get the available. I'm going to do that for my LiDAR array, very similar to Scott. I'm going to go ahead, except I'm going to do something a little different than Scott. I'm going to use the same sensor because he has showed it to be very reliable. So I'm going to use that sensor, but I'm going to mount it on a servo so that I don't just have to have 3 angles. If I get stuck, I can swerve them around to try to find the opening and decide on my exit strategy from the obstacle based on that. Now, and I'm also considering very hard to use some assumption like David did to, not get stuck in the first place. So we'll see. I'm feeling good about those. The ones I'm having more problem are the WT901s. Those are an IMU. Oh, that's what I wanted to tell you guys about, if you don't mind me jumping in here. Do you remember last week, Jesse made the comment that he uses BNO 055s all the time, but he does not use the
Magnetometer.
Yeah, the magnetometer, because there's a problem with the BNO 055 in that it continuously updates its magnetometer. And the problem with that is, you're going okay, and all of a sudden it decides to change it, and it doesn't work well. Also, probably another bigger problem, if you haven't got it done in the beginning, is that if you don't calibrate the compass, essentially it won't work. All right. When I say it won't work, I don't mean it's uncalibrated. I mean it just screws up. Okay. So, but I came across an article where a gentleman, and let me see if I'm going to go switch to it and maybe share it with you, where a guy seems to have solved at least some of this. Okay. I don't know if he's got it all. But also when we get, after you see this, I'll mention a strategy that he suggested, or he or somebody suggested, that might overcome the issue and allow you to get more reliability out of I think it's called NOF. or N9F for mode of the BN 0055. So let me go find that, and please bear with me. I don't want to. Where is? It is. All right. Just open up another CAD tab here, and hopefully magic happens and it goes right there. Okay. All right. Now we can do this. No, not that.
Yeah, I know Adafruit did an upgrade to the BNO 055 library.
Yeah.
I don't know what she fixed or changed. I noticed that when I opened up the Arduino IDE, it says, you can upgrade boards and libraries, and that was one of the ones that zipped by, and I thought, okay, well, she's done something to it. But
Yeah. Well, I wouldn't be surprised if this was added into it, because I think he gives links to where he modifies the library. So let me share this. All right. So this is the article, and I'll link it in. But here's his demo. I think it's his demo. Hold on a second. There it is. Oh, I hate this. I don't put up with those when on my.
Is there meant to be audio coming through?
Yeah, they're supposed to be. Here we go. I'll do it again.
There's still no audio.
No, but you should see captions on the screen now.
Yep.
You guys see that?
Yep.
doesn't play darts. Yeah.
Can you hide that label that's overlaying text, Doug? That's crazy.
So here's this little routine that he's going to use.
I wonder if he actually has to turn it that slow.
I think it helps. You can do it more than once too. And this is the part that he added to the library. So next time when he turns it off and turns it on, it's already calibrated. All right. Now, obviously, a lot of other IMUs already do that. Okay. But B&O's 55 has been a little bit problematic with that. See, I think if you do it that way, where you just do it multiple times, you can get the same thing. You're just trying to get the max and min. That's the part that's kind of the magic, because usually the way the Adafruit library used to work was you had to magnify, you had to do it every time.
Cool.
So he's storing that on the EEPROM on the.
I think he's going to talk about it here in a second.
Okay.
But yes, I think that's what he's doing.
I forget what it's called, like 2 KB of EEPROM or something. Yeah, it's the bank dedicated ferrets. Yeah.
Yeah.
He must have an interesting accent.
Yeah,
Yeah.
gibberish in some form.
Well, Ray, you're using the BN055. Do you see those kinds of problems?
I calibrate it every time I run it, so I don't store the values because
Oh, really?
I don't know, just haven't done it. And what I've called the chick magnet tells me, whether the system, the accelerometer, the magnetometer, and the gyro, what level of calibration each of those have. So I pretty much know before I start out whether I calibrated it right.
Yeah, I think the real problem, like I said, is that the BNO 055 continuously calibrates. And so you may have it calibrated first of all, you may have it calibrated when you started, and then somewhere down a little later, all of a sudden it jumps 15 degrees because it is now recalibrated. Okay. And that leads to one possible, I don't know, I can't find that little thing. I don't know how to stop sharing. Oh, there it is. Okay, so one of the things that you can do is, now that you have these calibration constants, is you can go in there and you can monitor them, and if they change, you just reload them. So you just keep reloading as you need to the same calibration constants that you started off with. So it is one possible solution to overcome that specific problem. So anyway, there's, I have on one of my sensors, I have a GPS with a compass, and that one is very difficult to calibrate, because it doesn't do any fusion, it doesn't do anything fancy, it's just a compass, and you just calibrate it and it stays that way, unless you change your environment, and so that's, I think, what that is kind of what Jesse, if I remember right, is what he's doing. Otherwise, he's not using the compass in the BN055, but I think he's using a compass. Now, I may be wrong. I'd have to look at his presentation from last week, but just a compass is pretty easy to calibrate and get on.
That's interesting, because I'm using the BN055 on Mobot, and I'm just looking. I was just looking to see where I might have dealt with calibration, and I'm using an example that I got. I thought it was off of the Adafruit, but somewhere in there, I do a BNO.get calibration, and it pulls the calibration out of the BNO, is what I understand.
Right. Well, which is what I think he's doing. So what I'm just saying is, maybe, like Ray said, maybe this is less of a problem than it used to be, because maybe the library's been updated. Okay. But I have had the BN055 just kind of go squirrely.
Huh.
You know what I mean?
Wow.
And so I'm just saying is, now as a gyro, so it's pretty rock solid.
Yeah.
Yeah. I have in gyro mode, no issues at all. And but I really,
honest, I'm not very dependent on the compass heading, because I'm mostly using steer to the waypoint. So,
well, I use that too, but I'm not using RTK, so right. I have to be moving before I get a heading from the And the problem is when I'm far away from the cone, the GPS heading is very good or reasonably good. It's off a couple of degrees, but who cares? You got 100 yards to go.
Yeah.
And the problem is as you get closer and closer and closer, it becomes more and more and more important.
Right.
So you can't, I'm not saying you can't, because I've seen it done where people have used a GPS and got down close and then, searched for the cone and found it. That strategy does work, but, it's not a case of where you're just going to be pointed at the cone all the way necessarily. You'll be getting some point and all of a sudden your waypoint your GPS coordinates will jump 10 yards to the left, and all of a sudden, but you only got 25 or 30 yards to the thing. Yeah. And so all of a sudden it's important. It used to be really a pain when, I'm sure you've all had a GPS, 99% of the time it's within 5 yards, but 1% of the time it's in your neighbor's backyard. You know what I mean? And that's when what you don't want to happen on your run. But by the way, I don't know if Kareem had competed, so he might not have realized that you had used RTK just on the run you showed earlier. Yeah. All right. I guess I'm pretty much hit the points that I think I wanted to do. There is one more link I might put in. There's another guy who has a YouTube channel. I'll find it and I'll put a link in. Who really does a great job of, if you're just using a compass, he pretty well kills it. And so I'll put that link in too. But I'll try to get these links going here. I got a lot to do here. So who's next? Open mic or what?
I had a question for Paul. Paul, when you're in, I guess it's
Hey, David.
RTK fixed, and float and then fixed. Float is less accurate, right?
Correct.
Okay. Is there like a figure of merit of accuracy for, is it a meter in float, or is it less?
It gives you a number, but I really don't know that you can count on that. My experience with high precision GPS is, particularly on the trucks, is it only just works, and it can lie to you and tell you it's accurate when it's not. Okay. So, and then just some stuff I was reading on the web said that float could be a meter off, or it could be quite accurate, because it's really trying to, home in and find the spot where it can transition to fixed. But there's no constraint that I know of on how accurate it is or isn't when it's in float.
Mm-hmm.
Fixed is where you want to get to.
Right, then you're down to 1 or 2 centimeters maybe. But
that said, Mobot did most of its run in float mode because after I had to put the antenna down on the robot, and it still did reasonable. So I'm not going to say it doesn't work at all. I think it does work reasonably well, but it's just, I don't believe it's specified.
Mm-hmm.
And I have watched it in float mode. There's a display you can put up in U-Center, which that's a tool that you use with the U-Blocks chips.
Right.
And it shows the deviation, and you see it like wandering around when it's in float mode, whereas in fixed it's just right there.
Mm-hmm.
Tom was next, wasn't he?
Yes, I do have a couple of things that might be worth mentioning before at my place on the list. I've been doing some work with digital compasses as well. Not the BMO. I've been working with the Honeywell 5883 and its clones. I started doing some work on this a year and a half or 2 years ago for another project. Did a lot of research. Part of that research involved looking at all the available libraries that could be used to interface to and theoretically calibrate that particular digital compass. Most of those libraries do not do calibration, or they do it poorly or incorrectly. So I ended up writing my own calibration routines, partly so I could expose all the calibration details so I could do my own analysis of how well calibration was working. I was asked a little while ago by one of the members of the Vancouver group, who's working with a submarine robot, to ask for some help on how to place a digital compass on his submarine underwater. He's found that as soon as the water gets murky, he has no idea which direction his submarine is pointing. So a digital compass seemed like a good answer. He has a compass, although he has no background in how to program embedded computers. So our process has been not only about compasses, it's about programming Arduinos and installing libraries and a number of other things. We're at the point now where he was unable to use the packages I built for my Honeywell 5883 because he doesn't have a Honeywell. He's got a Chinese clone. There are several of them out there, and they don't work the same way, of course. So after some research, we were able to come up with a library produced by DF Robot, which actually automatically detects one of several clones of the 5883 and provides a way to interface to them successfully, not only to my own Honeywell, but to his Chinese variant and to several other Chinese variants that are floating around. We're still using my external calibration routines simply because the DF Robot logic, although it contains all the structures to do calibration, simply doesn't do any. It says it does, but it doesn't do any calibration. So we're using my calibration routines. So he's at the point where he now has a compass working, and we're in the process of working on what the topside displays will look like. So he's working through the learning curve of how to make I2C links to displays work, and we'll get there soon. Then we'll build an RS-45 link between the two of these because his robot runs on about 50 meters of tethered communications cable. It's a very interesting project. He has his submarine running. I've seen YouTube videos of it running underwater out in Vancouver. So it's kind of an intriguing project. So I think it's going to work out well for him. Once we get the basic compass going, then we'll take a look at doing some tilt compensation on the compass and probably providing some additional roll and tilt information for the submarine itself. So interesting project going forward, I think. And Paul, since you're here, give me a minute, I'll pass you a link. The latest Roomba.com Java program set that I found is dated 2017. I've been able to import it into a Java development environment, but when I test it, I get hundreds of errors, primarily because it contains a substantial number of libraries, references to libraries like log4j and some others that simply don't exist on either my Linux or my Windows systems. So I'm slowly working my way through the exercise of trying to figure out what's missing and where to put it in order to get this thing to compile successfully. I've acquired a half a dozen Roombas in the 4000 and the 500 series that I'd like to experiment with as robot platforms. But first, I'd like a simpler way of testing them, because talking to them over real term using the API for the communications interface is a really tedious exercise. So that's where I'm at with that one. If you have any thoughts or advice, I'd certainly welcome them. I haven't done Java programming in a long, long time. Okay, that's it. Any questions? My compass applications are somewhat simpler than the BMO compass. They're only 3 dimensions, but in my experience, they work very, very well.
Gosh, it's been so long since I played with the Roomba, Tom. I don't.
I was so amazed to see a name I recognized in the forums.
I don't know if I've played with it since about 2012.
Yes, it used to be hosted on the Dallas website, but it's not there anymore. It's on GitHub in several places in different revisions. 2017 is the most recent one I found.
So I only ever, as far as I'm trying to remember if I even used it under Windows or if I only used it on Linux.
Yeah. I can run it either way, but I'm a lot more comfortable working in Windows than I am developing in Linux. Linux is more of an appliance for me. Windows is more of a development environment.
Well,
anyway, any thoughts anybody has, I'd welcome.
I'm sorry, I'd have to search deep, and I can look a little bit, Tom, and see when I last did anything with that, but it was a very long time ago.
Yes, I know. I understand that problem.
Got to say, Blue Steel's background looks pretty warm and cozy. That's got a little snow out there, fire burning, you know. Can't hear you.
So I've got, if anyone else has anything, go ahead. Otherwise, I've got a topic that is maybe of interest to some of you. I'm not sure. It's Docker, and so the background to it is that I want to upgrade my laptop. It's currently on 20.04, which is the highest that I can. Ubuntu 20.04 is the highest that I can go and still use ROS1. So I've got the ROS1 Noetic distribution installed, and but I really want to get my laptop onto a more modern OS. 22.04 is the current version. 24.04 will be coming out early next year. And so I've got this problem that I've got a fair bit of ROS1 software that I'd prefer not to let die. So a Docker container, a ROS1 Docker container seemed like a way to keep it running while after I upgrade my laptop to a more modern Ubuntu OS. The other scenario where I think it could be useful is I'm running ROS on an Raspberry Pi on the robot and under Ubuntu Mate. But Ubuntu Mate, which is like a simplified version of Ubuntu, so Ubuntu Mate 20.04, same problem. It'd be good to get a more recent version, but really even using Ubuntu is problematic. I had a heck of a time one time getting it to boot off of SSD attached to the Raspberry Pi, and I haven't been able to duplicate that feat. It just won't. Ubuntu Mate just doesn't want to boot off of an SSD on an RPi. And so that's a situation where a Docker container could be useful in allowing me to run ROS1 software under the native Raspberry Pi OS. So in service of all that, this last few days, I actually got a ROS1 container up and able to run the GUIs. So that's the holy grail with Docker containers, is to run the GUIs. It's, you know, there are stock containers that you can get from OSRF that will run ROS1 on whatever platform you're running your Docker container on, but getting the GUI is a little difficult. So what I want to show is that happening. So I'm going to present a share screen here. And which one am I on? I think. There we go. So are you all seeing the X window here? The terminal? Is it readable?
Yes.
Yeah, if I get close enough. It's pretty tough.
So I don't know whether I've got an architecture drawing and I've got a demo, and I don't know which to do first. Like, should I explain what Docker is and with a diagram first, or demo it running first?
Either way.
Probably explain what Docker is first.
Okay. All right.
More efficient virtual machine.
It is.
Virtual environment?
Yeah. It's a little more efficient, takes better use of resources of the computer, doesn't hog them like a virtual machine does.
Yeah. So are you all seeing this diagram?
Mm-hmm.
So this is what I'm about to demo working, and the big dotted rectangle around the outside is my whole laptop. And what I'm going to show is a simulation, so running Gazebo with ROS software of running Mobot. And so in the past, I've showed that running just natively in the laptop, and I've got all the ROS software in the laptop installed, and it all runs on the ROS libraries, which are on top of the Linux kernel, etc. What this new development is about is taking a Docker container, the ROS Noetic base container provided by OSRF, which contains the ROS binaries and libraries that are stock that come out with ROS Noetic, and layering on top of it my ROS1 container layer, which contains the Mobot binaries and libraries. So the way container, as Karine said, it's a more efficient virtual machine, but it's really important to understand that it's different from a virtual machine. It doesn't run its own kernel. It has the container uses Linux kernel calls and runs in an environment inside your laptop OS that is separated from the main OS. So a way to think about it is you've got a Docker file system which has / and /etc and /user and all of those directories, as well as /home/bushier, and under that is /home/bushier/catkin or /rosws, and that has directories source containing the Mobot source code, and devel and build, which is where all the development happens. This is on the laptop when I'm building on the laptop. Well, Docker has its own region of disk that actually is just a file, but it knows how to use the file as if it were a file system, and that also contains /user /opt ROS and /home. So I created /home/Bushier in the Docker file system, which is separate from /home/Bushier in the main laptop file system. So you got a kind of a limited environment. But a key thing that I did was to mount the source directory off of the laptop ROS workstation /ROSWS/source onto ROSWS/source on the Docker version of my Catkin tree. So then what that lets you do, I'm diving real deep here, and so I'm apologize if I'm losing you. I hope it'll make sense in a little bit with a demo, is I start up a new shell running in the container that has the environment of this ROS1 laptop environment that I set up. It has its own file system. It doesn't even know that the file system is inside of my laptop file system, but it has access to the same source directory, but its own devel and build directories, and everything else is private to it, mostly everything else. And then also in the laptop container, in the ROS1 laptop container, I put in a VNC server so that I can launch the VNC server inside of the container. And then, I forgot to add that part to the drawing. Imagine there's a virtual, inside this container, imagine a virtual screen, which is the X window screen that can show the ROS GUIs, and imagine a VNC link out to the real screen on my laptop, or I should say out to a VNC window displayed on the real screen on my laptop. Are we like really lost by now? Maybe if I show it.
I'm following.
Okay. Okay, where did my there we go. So I launch it with this. So there's a couple of scripts here, and by the way, just to show the difference here, ls tilde in my, listing the directory, the home directory of my home contents on my laptop here, and this still needs a bit of tuning because you can't tell the difference between whether I'm looking at a Docker shell or a shell on the laptop, but there's lots of stuff. There's stuff in my home directory. Now, I made a script, ROS1 laptop.sh. No, it's not there. It's run ROS1 laptop. So it basically just issues docker run, the docker run command, invoking the package called ROS1 laptop that I built with all these extra packages that Mobot software needs, telling it to use the network, use the host's network, so it become any sockets that it opens become sockets on my laptop. Not that that's terribly significant, except from point of VNC, because if I run a VNC client on the laptop, then I just
Actually, Paul, that is very significant because what most people don't realize when they get into Docker for the first time and they try to do the mounting thing you're talking about and talking to services and all those other sorts of things you want to talk, what they don't realize, unless they do that host flag in there when they fire up their Docker container, Docker will make its own private network inside of your machine. So even though you're on a private network, it makes another, here's your machine network, it makes another private network inside of that. And normally those two can't talk to one another directly for doing all your mounts and accessing web pages and whatever else you've got going on in your Docker. So that host thing is like crucial for doing what we would like to do with our robots and other things.
You're right, Harold. Yes. And for a while I didn't have that, and I had to use SSH.
Yeah, it was a pain, right? It was a
yeah. Or had to use an SSH tunnel specifically to get VNC to work. So anyway, this made life a lot easier, and you're correct there. And then this -V flag mounts a whole bunch of, or several of my laptop directories onto corresponding mount points inside of the container. So this one particularly, -V, mounts my home/catkinws, which is my ROS directory /source. So here's where I share the source from my laptop onto home/catkinws/source in the container. So here I'm sharing the source directory, but not the devel and build directories under catkinws. And then there are a few other shared mount points, like bash history, which is nice. So you can share the bash history between the container. So if we run /run that, it starts up real fast and dumps me out in the home directory. Now I'm actually inside the Docker shell here. The only reason I know is because I don't have a colored prompt. But if I do ls, you can see there's only two directories there, catkinws and packages. I am in a home that is inside the Docker container at this point. So now the thing to do is to run BNC server -depth 16 -geom, say 1600 by 1200. And that has now created a display called :1 on this Docker instance. So inside of the Docker container is a virtual screen that things like ROS can display their GUIs on. So like RQT topic, RViz, etc. can display the GUIs on the screen inside of the Docker container. So now the thing to do is to go, and I'm not going to share this because you all know how to do it, is to go to the desktop client and now I will share, I'll just change what I'm sharing. Share the window. That is Ramina. It's the VNC client I use. And I've just asked it to go to localhost port 5901. And that is not actually the right window that I intended to show. Where is it? Window. There we go. There we go. So we enter the. Okay, so this is now. VNC window showing the virtual desktop inside the Docker container. So from that Docker prompt that I had before, I'm going to start up Xterm. And there's Xterm popped up. So now from here, I can run ROS launch Mobot, bring up Mobot Gazebo, gzmo.launch. And there's the Gazebo window and the RViz window, which starts out massive and I need to shrink it. One of these times I'll remember to save the config. And yeah, so unfortunately something's not working right, because when I try and drive it somewhere, it doesn't move, and I don't know why. So you know, it's not all happy, but Xterm as an additional, if we can do RQT topic. And here's RQT topic here. And look at, for example, command bell. And looks like there's no data coming across this. If I try and drive it somewhere with the robot steering app, we get some linear X acceleration, and we can like. So anyway, that's as far as the demo. As far as the demo goes. So then, just circling back to the block diagram to just revisit briefly what's going on here. So what I just showed was launching the ROS1 laptop, launching the ROS1 laptop container, ROS launching a Mobot launch file, which launched Gazebo and RViz, and also RQT tools. So some of them provided by the ROS Noetic base release, and some of them provided by my sources, like the scripts, are in this source directory, which is mounted off of the laptop file system. So it's like kind of circuitous, but it does show, I think, that you can use it, that I can now safely upgrade my laptop to a newer OS release and continue to run Mobot software in simulation, or actually on the real robot, inside of a Docker container. And it also provides proof of concept that I ought to be able to run a Docker container on the Raspberry Pi running the native Pi OS without messing with this Ubuntu mate stuff. So that's it. Any questions or thoughts on that?
Paul, any feeling for what the overhead in terms of memory consumption or CPU time consumption is for running all of this stuff inside of Docker?
That's a really good question. And
You're going to want to know it on a Raspberry Pi, I think.
right. That's a really good question. And I think a way to address it, if you'll give me just one more second, is to share out. I've never actually tried this, but why don't I share out this window and let's see, this is the one. Yes. So let's run top. Let's see. So I'm running this. Let's see. Just to make sure. Okay. So I can see I'm inside of the container now because my home directory only contains cat and WS and packages. And I'm running GZ client, which is consuming 4 CPUs worth of compute power, and RViz is consuming about 1, so it's about 5 CPUs worth. GZ server is so this thing's pretty heavily pegged. Now let's just see what top shows running on the laptop. Okay, that's pretty much the same. So if we say that tasks are consuming about 429 percent of CPU power, then what I'll do, just as an A/B comparison, is to exit the NC client and log out of the Docker container. So I'm back in my laptop now, no longer running. LS tilde shows me all my directories. Now I can ROS launch Mobot Gazebo, and this is what I won't be able to do.
Paul, are you sharing the right screen? I don't think this. Yeah. Yeah, you've been talking, but we hadn't seen nothing.
Thank you. Sorry. So I'm back on the laptop. I've stopped the Docker container, and I'm going to relaunch Mobot Gazebo gzmoa.launch, and this will all fire up. So it's just fired up Gazebo and RViz and all that jazz. So now let's look at top. Okay. I'm sorry, I looked at the wrong thing. So the load average is coming down to around 8. And on Docker, the load average, when I ran it inside Docker, the load average was looks like around 21. So a lot more tasks were ready to run on Docker, which indicates there was maybe there was a significant slowdown. So, it's a good question. Significant slowdown, I guess, is what
I had a similar question. I just installed ROS on my notebook using VMware. What do you think of VMware versus Docker?
I have used VMware, and VMware adds a lot more overhead. VMware was difficult to use. Ours was really, really slow, and I could only maintain about a 3 hertz loop rate from my laptop to a Roomba robot years ago when I tried it using, actually not VMware, but using VirtualBox as a VM. So yeah, VMware is, just from my personal experience of the level of responsivity, the VM is a lot slower because it's emulating the whole kernel, whereas there really isn't any emulation going on in Docker. It's just libraries in a isolated environment.
Yeah, those are two vastly different products. Docker and VMware are two vastly different products.
Yeah.
Okay, so using Docker, you're running the Windows version, or do you have a Linux notebook?
Sorry, say again.
I think I have a Windows PC, and I was trying to run Linux.
So what you probably want to do with that, Docker runs best on top of Linux. There are Windows containers that you can do, but if you're running a Windows box, this is coming from the Microsoft MVP here. What you really want to do is on a Windows box, you want to install Windows subsystem for Linux, and then after you do that, you'll install a little bit of Linux onto your box. Usually Ubuntu is the selection of choice there, but you can do very much different ones on there. But once you get the subsystem for Linux going on, then you're running your Docker Linux containers on top of Windows, you'll have a much better experience.
Yeah, I was seeing stuff about WSL Windows.
Yeah, it's actually really cool how they do that, and the WSL is not too much different than the Docker container because you've got this Windows kernel, you've got this HAL hardware extraction layer here, and then you've got Ubuntu Linux, like you can install straight on your hardware because as those calls are being made, it goes to the hardware extraction layer that changes them to make actual Windows calls underneath. And so once you have that going, you have this well-known interface that Docker's going to run on and their Linux containers are going to run on and do a really good job. Now, there's people out there that will complain that the file system doesn't do this or do that. And there are problems. I'm not going to lie. But they've made significant strides. If you use WSL, let's say 5-6 years ago and said, oh, it's crap, I would ask you to try it again because they've done significant strides on how all that stuff plays with one another. And
I was just reading that it said something about it's really hard to get like serial ports and USB and stuff.
Yeah, that's a difficult thing on a Windows box, running a Windows container and getting USB and serial ports. Sometimes that can be problematic. That is true.
I think you're probably better off, and really what I've just shown is an intermediate stepping stone towards the final goal of upgrading Mobot to run ROS 2. And if you use Windows as a dev platform, I think you're probably better off with ROS 2, which will run natively on Windows.
Yes.
Yeah, they have a Windows version. I was just, okay, all right. Like I was just worried about moving files like from the Windows version into the Raspberry Pi because it's going from two different operating systems. And you have to do a translation, a conversion. I don't know. All right, so I just, okay, well, I think I'm up next, so I'll let Paul finish. Yeah.
That's a really good question about, you're really talking about how do you get a ROS environment that runs simulations of your robot under Windows and also runs the real robot on a Raspberry Pi, which is a Linux platform.
Mhm.
That's a really good question.
Yeah, so I'm thinking of doing a dual boot. Yeah.
You know something, Paul? Docker's a good way to make that happen.
Yep, I reckon so.
The dual boot run either Linux or Windows on my computer, on my laptop. Okay.
I'm on that same journey. I'm actually trying to figure out, do I do Docker or do virtual Windows, a virtual machine? I'm actually using the Oracle VirtualBox right now, and I've made contact with a ROS2 Pi over Wi-Fi, so I'm making progress.
Oh, cool.
Yeah, you're supposed to be able to do that. Yeah, because it's running Linux on the PC.
But it's the ports. It's the ports that was the trick. Because,
Right,
like
that's
it was said earlier, it made a virtual environment originally, and I took the host configuration, and it worked out just fine.
Yeah, if you use that host parameter there, so the Docker and all that kind of stuff will use your local machine's host and ports and all that kind of stuff. UDP works. All the TCP stuff works. If you want to talk security, you just threw all that out the window. But at this point, we got some well-contained environments, right? So that's not our primary concern at the moment, and it makes it really easy to work, especially since ROS 2, ROS 1 maybe, I don't know, but ROS 2 works all over UDP for all its message passing and its talking, and so it's got broadcast stuff all over the place. And as long as you've got your ROS network ID set up correctly, they'll find people all over the place. I've got my laptop, I got my rover, I've got other stuff, and they all can talk to one another. It's really pretty cool how that works out. It worked way simpler than I thought it was going to work. I mean, okay, transparency. It took a while to figure that stuff out. I ain't gonna lie, but once I understood what they were telling me to do, that was the hard part. Once I understood they were telling me to do it, I did the 3 or 4 steps they told me to do. Miraculously, things just started working.
As long as they're in the same network, that's.
Yeah.
I was surprised on how easy it was once I got the ports fixed. It just happened.
Yeah, it's like magic, literally like magic.
So that's all I had. I see Mike's got an update. If there's some more discussion on Docker containers and such.
So I'm trying to learn ROS 2. Might as well just go to the most latest thing. Because I have no history. And so I'm going through the tutorials right now and running it on VMware, but I'm wondering, is there a better way to do it? Yeah, so we talked about that. So last time I wanted some information on like where wheels and stuff. And so I took advantage of Black Friday.
Oh, somebody's been Christmas shopping.
So this is the wheel, or the motor mounted on the wheel. So I'm getting closer. And I'm making the. It's going to be smaller than this, but I'm making the chassis using a fiber rod. And so I've been 3D printing the corner braces to make it a really strong chassis. I think it's going to be about smaller than that, 2/3 that size, 200 millimeters or so, 300 millimeters. And when I went to print, I had to go somewhere. I pressed the print button, but I got spaghetti. My 3D printer. Yeah. All right, I'll run it again tonight.
Was that the print angel hair button?
Yeah. Yeah. And I do have I can show you the robot in 3D CAD that I'm working on, the mechanics. Let's see, yeah.
So what material was that you were trying to print? Was it Ninja Flex or something, or
It was just plain PLA,
PLA? Oh, okay.
plain garden variety PLA.
Mhm.
Because I'm trying to make it strong and not flexible. So, yeah,
Yeah.
I don't want Ninja. No. So,
Kind of looked kind of squishy, so I thought maybe it was Ninja Flex or something.
yeah. So I've been, that was what I was trying to print is this guy here, the motor mount right there. So that's my, and so this robot here, I'm doing it a little differently. I also took advantage of Black Friday on
Go Builda.
and I got those odometry wheels. And so I'm going to use the odometry wheels in place of caster wheels, and put my motors right in the middle of my robot.
Mm-hmm.
And yeah, I turned that motor off. Where's that? Motor. There it is. Yeah. So the motor mounts on that pad there, on that. So that what I was trying to build is the thing to mount the wheel onto that bracket here, and so I'll have one for each wheel and one for these corners, and get the odometries attached to the different versions of that. So I like to build my stuff this way, because like these rods, I got to put round holes through these braces, and so I just have versions of the brown of this and I just subtract it out. So everything's exactly the same size, everything's in exactly the same position. So as long as I have relatively good models of everything, then I can make these 3D printed components. Like I don't 3D print those. All I'm doing is right now is 3D printing these. Let me look at the top.
Do you have a way of clamping the rods though?
Yeah, I got screws right there. Yeah.
Oh, okay. So that'll squish down and.
So you can see here that.
Okay.
I have a slot in here.
Yep.
So but right now the rods are really tight, but they're not tight enough for execution. So I'm waiting for my screws to put in there, and I'll tighten it up.
Yep.
So yeah, it's that's how I'm using CAD on here, trying to just get an idea of this robot, and then since I'm trying to do it in ROS, I got to model this thing in ROS. So I've been watching some YouTube. So I've been busy. I'm gonna stop this sharing. Unless someone had some questions about the CAD, I was going to stop sharing.
Have you found that you have to print in like super fine detail to get the portions that are supposed to accommodate the rod to be like the right size? It can be like a millimeter off or something, because it's not a circle. It's like segments of multiple line segments kind of joined.
You did a really good job. I mean, the first one I printed, I said, okay, the bore through that is going to be 5.5 or 10.1 millimeters or 11 millimeters, for a 10 millimeter rod. I stuck it in there and it was way loose. So, oh crap, I'm going to do it at 10. I did it at 10, and it wouldn't fit in. So now I'm doing at about 10.4, and it has really good friction.
Yeah, isn't that weird? You have to kind of think it's Ackley's rule of three, you know?
Yeah, too soft, too hard, and just right. And then I changed the filament because I was doing it in white filament, and now I ran out of white filament, so I'm doing it in pink, and that's where I got spaghetti. So after the all here, I'm going to check the bore hole to see if it actually.
No, I don't know what your slicer is, but most of them, like I use Cura. If you're finding your holes are routinely, let's say, a number of millimeters too small or 0.2 millimeters too small, if you look on your slicer setting, there should be something called, well, some call different things, but in Cura it's called XY expansion for holes. And you can set that. And so what Cura will go out and see is say, oh, you want a 10 millimeter hole here. But he's told me, because you're a he and Cura's the Cura, that every time I go do a hole and they want 10 millimeter hole, that I make it point when the plastic comes out, because plastic doesn't always go where you want it to, right? That I'm making those when I'm slicing them and putting them down, the holes come out 0.2 millimeters too small. So what I will do as I'm slicing your model, I will expand or contract those holes. Let's say if they're 0.2 millimeters too big, you put a minus number in there, they get smaller, right? And so once you got your this is one of the things that you would eventually tune on your printer when you're doing a lot of printing, so that you don't have to do all the boring and do all the drilling out and all the other kind of stuff that you need to do. Or in your case, print the same print 3 or 4 times and changing the size of it just a little bit. Because once you figure it out what that expansion is, you can just code it in your slicer. Because everybody's printer is a little different. And I know even the manufacturer printers are a little different. A little tolerances off here, a little bit of something here, a little more wear here, that kind of stuff. So once you figure it out for your printer, all those settings are in there to help you dial your slicing and your profiles into your printer, so that if you download something off the net that says it's a 10 millimeter hole, you're going to get really, not just really close, but a 10 millimeter hole to the best of your printer's ability by setting all these little, if you go look in Cura, there's got to be, I don't know, 300 or 400 settings you can set. Most of them, nobody ever sets those things, and this is one of those things that you can go set in there that I've found very useful over the years.
Yeah, because the rod's 10 millimeters or 10 millimeters plus or minus, and I found one rod was a little bigger than the other rod. One fit, and the other one I had to work a lot harder to fit. so yeah. I gotta learn those.
Go look at that kind of stuff and play around, or after saying and doing all that, if you're good with if you have access to the models, right? Which you do, go change your model to fit your printer and be done with it. That works. That's what I do a lot of times too when I'm doing these things. I'm like, screw it, I'm not going to worry about that on this. I'm just going to make my model because I'm the only one's ever going to use it anyway.
So I made a master version of this rod and then did clones of it for when I was going to use it to drill out the hole. And so I just go to the master and it updates all the rods.
Yeah.
In the 3D model.
So what are you using the model? What are you using to do your 3D modeling?
FreeCAD.
FreeCAD, okay.
Yeah, I was going to have a question about that. Are you using it because it's free, or is it because it's free and it's a good CAD? Because I'm kind of looking for a good CAD system myself that's free. Are you compromising a lot because it's free, or you use it?
I heard Fusion's a little better, but I know how to use it right now because I've been using it a while. So.
Yeah.
Well, Fusion is free for hobbyists. They make it a little difficult to do it because they want you to use the real version for 30 days or something. Then when you go to license it, which you have to license it once a year anyway, you just say you're a hobbyist. And now there's some functions in it that they reduce some stuff, but most of the time I've not found I've needed some
Okay,
of those.
I had thought they had eliminated that, but you're saying that's still an option. Okay.
It's still an option. And it's
Okay.
when you go license it, you have to tell them you're a hobbyist or a whatever student. Students is a slightly different thing, but yeah, one of the two of those things will get you. And I don't want you lying, because you are a hobbyist and you may be a student. I'm a student of life, depending on how you want to play with that, right? And I've never used FreeCAD, looked at it. One of the reasons I stick with Fusion is because, one, they haven't tried to do anything nefarious, even though I don't like some of the stuff they took away, but I wasn't using them anyway. But it is a pro level tool. It's not that FreeCAD is not necessarily, but there are people using Fusion professionally right now, like SolidWorks and other ones. And I'm like, not that I'm going to become a 3D modeler as a profession, but I learned something that then I can, maybe use somewhere else on a happenstance. I mean, I'm a collector of skills, and that's one of the skills I collect. That's my theory on it anyways.
I find I'm just too impatient to wait for a 6-hour print. I'll use really coarse settings that, can accomplish something sooner in maybe an hour and a half or so. So then if my holes aren't right, I'll drill them out,
Yeah, I use 0.3 millimeters and it's pretty good.
Yeah. Quick, you don't have to wait for, half a day to.
Brandon, another one that you might be interested in or take a look at, it's one that I've used and I like. It depends on how your mind works. Okay. FreeCAD is kind of a constraint. I don't know how I can state this, but it's like you constrain your part, okay, to make it. And I don't think that way. And I visually have problems with how things happen in Fusion 360. Now, 360 is an excellent program. And if you're doing any CNCing, it's the best that you can get probably for free. But like I say, it's a little weird. The other program that I use quite often is Design Spark Mechanical, because it thinks a lot along the ways that I think. And I've just found it easy for me to learn. And it's like anything, and like I'm sure Mike says, he's put a lot of time in it, so now he can do all sorts of things pretty quickly. Well, with Design Spark Mechanical, I'm at that stage too. I can whip out a design pretty quick with it. But anyway, it's free also. They do have a paid version, but it's like $11 a month or $12 a month or something like that. And that brings a few extra features to it. I do use that, but you don't need it. I used the free version for years.
Yeah, well, I'm real primitive, and I just use these primitives to build stuff and a little bit of chamfering and make some of the cloning stuff.
Yeah.
I need to learn how to do the more sophisticated.
Another real popular design software that's free is Onshape.
That's what I use. Yeah, that's what I've been using. It's good for collaboration too.
Yeah. And there's a cat out there by the name of his YouTube channel is Teaching Tech.
Yep, that's where I got it from.
He does a fantastic job of explaining things, does great videos, and he has a whole series that's taking you through doing pretty much most things like 3D modelers or printers need to do on the thing, and he does a really good job on that. And if I ever decide to learn Onshape or whatever, I'm going to just go to his playlist and hit play and do whatever he's going to do.
Yeah, he's the one who because I was looking for resources. If I chose one, I needed resources to help me build stuff, and that's exactly why I chose Onshape. And I have a friend that we kind of collaborate on projects with. And it's seamless.
Cool.
It's a web-based, for y'all who haven't used it. It's a web-based CAD system. Mm-hmm. So collaborating with other people is seamless.
And also, Fusion is is a web-based sort of thing too. So there's kind of the downside. Like if you lose your internet connection, you're not going to be fusing or on-shaping. But that also means that your laptop or your desktop or whatever, if you can bring up the page and do the thing, you're not going to be constrained with the power of your laptop or your desktop as much as some other systems, because there's processing that goes on up in the web and you're seeing the results on your box. There's some stuff that happens on your box, but there's other stuff that happens somewhere else, which is actually kind of cool and not cool at the same time.
Yeah, so I also got some sensors, and I was intrigued by Ray's his 3D LiDAR little box that he had. I mean,
oh yeah, the Cyped A, yeah, 010, I think. Yeah, that one.
Yeah, I guess.
Yeah.
The one that. Yeah. So I was looking through here, but so they had a LiDAR chip that had an 8x8 3D LiDAR. So I was gonna need to fire it up and see how it worked. And then they had it was actually a time of flight sensor. Sorry, time of flight, which is similar. But it's a little teeny, looks like just the regular time of flight ones, but it does an 8x8 matrix.
Right. Yeah.
So let's try it.
I don't know if it's Palulu or SparkFun. I think they probably both have, a breakout board for that now. So.
Right.
Yeah, I've got one from Pimoroni.
Yeah, and then I got an interesting one here that has a 3-channel wide field of view time of flight distance sensor, and
oh yeah, from Palulu, yeah.
From Palulu. So I was going to use that like for the rear backup detection, sort of get some rough things. It's sort of like the robot that had those 3 sensors on the front, but it's a little one for indoors. So I got lots of toys to play with now.
Oh yeah.
I was looking into, instead of paying $80 for an odometry pod from GoBuild, I was thinking of making my own for the outdoor robot and using that as a obstacle avoidance, if kind of like they did for the Rhombas, the little black-white wheel. If it's not turning, you're stuck, sort of thing, and maybe not have a bumper on the front. So
I was going to show what I was doing here, which I.
Sorry, Bo.
So basically, like for the mechanism wheels, which can go left, right, front and back, and rotation, it needed 3 odometry wheels. But since I'm only doing forward and backwards and rotation, I'm just going to have 2 odometry wheels. Like this is the one that senses the X motion, and this is the one that senses the Y motion, which is basically the theta, the angle. So I was able to bring it down to 2 instead of 3. So, and I'm going to build this robot where the center of the robot is the center of all the sensors, just to make life easier. So basically, I was looking. I actually bought 4 motors. I was thinking I was going to do a differential skid drive, and I decided, that's really complicated, and they slip and everything. So I decided to do this with 2 motors, and then 2 sensors instead of 4 motors and 2 or 3 sensors. So. So I'm hoping that this is a good design, and I'm hoping these can work as casters if I put a stop on them, so that.
Oh yeah, they probably should. Well, I guess they're spring loaded, right?
Yeah, they're spring loaded, but I need to put a stop so that it just only rotates just a little bit. and then goes to a hard wheel, and the other one doesn't lift off because it's sprung. Like when you're accelerating, it'll lift up the back and point down the front a little. So that's gonna be interesting to get that all running and get it modeled in ROS 2. I haven't seen that model of a robot in ROS 2 yet. Just looking at YouTubes and stuff. So. But it claims to be, well, you can build anything in it, so it can be done.
So is that robot a unique design, or are you patterning it after some other robot? Because I did not recognize it.
Oh, I'll bring it up again, but it's unique. I mean,
It looked like it. Yeah, that's what I was thinking.
It's like So normally you have two wheels offset, or a big ballast, and then one caster wheel. And
A tricycle, but you put a fourth one there to get a different axis measurement.
Oh. Oh yeah. But this was a caster wheel. Like these are Omni wheels, so they work as casters. They can go slide back and forth in any direction. Yep. These Omni wheels are, the odometry wheels. I guess they're called. What are they called?
Yeah, they're odometry. I went to the website that you mentioned and I looked at them. Yeah,
odometry pods, I think is what they call them.
Yeah. So they're using Omni wheels. So it's a good caster.
Yeah.
Also odometry. So, and then I need two of them, so I got two casters, but yeah, it's a little mechanical thing to work out. Because you don't want them hard to the ground, because that way if it runs over any irregularity, then the regular wheels will lift off the ground. And you've got a little bump to go over.
And this is designed for the cone obstacle course. I'm not sure what you guys call it, but I've seen the videos. Is this robot for that, or is it more general purpose?
It's going to be, for the can and the can do one.
Is that the competitions you call them, can and can do?
Four square and 6 can.
Those are the two.
And then there's quick trip if you want to do quick trip too. That's the ones we usually do.
That's the cone obstacle course?
No, the cones are outdoors.
Yeah, this is indoor.
It is an indoor, and you're in a 7x10 arena with openings at both ends, and essentially you have start at one of the edges, and you have to push 6 cans out the other side.
Oh, that's a can. Okay.
So that's called can.
You have to identify them and move them. Okay.
No, and then there's when we have 2 robots, one on each side. That's called can soccer, and you can't purposely hit another robot. So there's no defense, but robots will be robots, and you'll probably hit a robot somewhere along the process. So until we have a sufficient number of contestants, we're going to be doing can probably. But once we get can, a lot of people do up to can level will do can soccer probably.
I wish there was something like that out here.
Yeah.
They just want to do the fighting robots, the remote control combat robots.
Yeah.
That's how they're do out here.
Those are just RC cars with a vengeance.
Absolutely.
They're not really robots, in my opinion.
Absolutely. Robot means to me autonomous. So, and nobody else thinks that out here.
Yeah. Well, we've got, we've done over the years, we've done a variety of contests. The one I'd like to bring back, even if we didn't use that particular project, is Donkey Car. Because that is just cool to watch.
Yeah, it is.
But I don't know. That takes a whole another level of getting ready. and we only have until May. So something to think about.
So Brendan, I put and for anyone else that doesn't know, I put links in the chat for the DPRG rules.
Yeah, I
And
just
you can
brought
either
that.
find them on our website or in the DPRG Git repo.
Yeah, I just brought that up. Yeah.
And what we started to do, especially over starting with the COVID stuff, where we really started to go virtual and drag and attract folk from way out beyond Dallas, is when there's interest. If someone has an interest in a contest, one or another, we'll do whatever it takes to make the rules suitable for multiple sites. So if there's one of these that grabs your attention and you want to like whip up some interest and talk someone else in the club into going up head to head with you, just say the word. And it doesn't take much to throw a mitten down and have somebody take it as a gauntlet. And pretty soon you got a contest.
Right.
Yeah. Brandon, take a look. Did you put down the Robo Columbus?
I see that.
If you look at that, if you look at the Robo Columbus and you're sliding, you'll see about, I want to say the top third, it talks about remote competitors. Okay. So, we try to have the ability to do remote competitors. So, like last year, we had a gentleman in Canada named Pat who did Foursquares, and he did very well. He basically set it up in one of his larger rooms, and I don't know. He may have been in someplace else. He might have been in like a community center or something. I can't remember
I remember. Yeah, he went pretty far out of his way to get a kind of a public space that he could use that was big enough.
Yeah. So I'm just saying don't think just because you're remote you can't compete. Now, in fact, it's actually pretty good because the people that compete remote, they're in a separate prize pool. So, if you're the only one, hey, that's
yeah.
But
okay, look at that. Yeah.
Look at it. The rules might be a little different for indoor competition, but where it talks about remotes, and I think there's a remote competition document. You can go to that and kind of get an idea.
Yeah, I'm looking at that. Right. Okay. So I could actually organize a group out here, and we could have a kind of same day competition, and
and we're even more flexible than that because you might not be able to do it on the same day.
Right.
So maybe in a week, or something like that, where you set it up because you might not be able to do indoors easier usually, but outdoors might be, like for example, if Pat tried to do outdoor in November 18th, he'd have 20 feet of snow to screw around with. So it'd be a little different for him. So
didn't he last year? I think. It only takes one. You don't even need a group at a different site than now.
Yeah, that's right. You only need one. But I'm just saying, if you got some buds and you want to go ahead and set it up, we'll compete locally. And like I say,
I think Pat did his video. I think he did his run like a month earlier, so he could get it done outside before the snow came.
Yeah. So that's just showing. You know what I mean? Mm-hmm. So it's pretty flexible. Look at the rule set, and the only thing it's flexible. The rules are there to just kind of like give you some ideas on how you can set it up.
Who is it? Is it Spark Fund would have that annual event where it was outdoors. They had it was GPS, waypoint type avoidance.
That's the AVC. AVC. I got AV is right. Autonomous Vehicle Competition, AVC.
Yeah.
Okay.
That's when I actually, my past robot had a IMU and GPS guidance, and it had artificial behavioral programming to kind of navigate the near-term obstacles.
Yeah. Mm-hmm.
And I was trying to build one for that type of competition.
Yeah.
That's what I gravitate to.
Yeah. You might want to look at last week's.
I looked at those videos, the snippets.
Because Jesse is doing something that's going to be about. He said about in 2025, but it's some really big competition, and it has similar cars.
Well, DARPA has actually had these competitions for that because they're interested in having true autonomous vehicles to follow around the troops. Yeah,
but I don't think they're doing it anymore. Not.
Nobody could achieve the objectives.
Yeah.
So it may be different now, but this is like 5-10 years ago. DARPA never could have a group could complete the objectives.
Well, I think they did. They actually, and so that kind of like changed the thing. The last one I heard about was done by NASA, where they went to a college campus that had like a large field, and they took some different objects, like maybe one was like a golden painted cube, and they just had them out there somewhere out in this humongous field. And you started on a platform because supposedly that's when your spaceship came down, and you're on the platform. You weren't allowed to use any GPS or anything like that. And you had to try to pick up these different items. Like I say, one might be, I want to say they were about the size of a softball, of different shapes and things. And, it's very hard, when you're trying to, because there wasn't, the field was just like, think of it like a football field, but maybe a little bigger. And it had trees and stuff in it. And you're out there, you have no idea where it is. Mm-hmm. And you got to try and find it. And, even though I think they had five objects, I think the winner actually found one. And he was the only one that found one.
I'll have to go back and find that. The one I remember is it was DARPA, so it was a wilderness four-wheel drive type of large vehicles, and
that was 2005 through 2007. And
that's about the that's about the time frame I kind of dropped out because of work and stuff like that. Yeah,
but they really kicked off the autonomous vehicle movement that we're seeing in robo taxis and such.
Yeah. So
I have to go back and see the NASA one. I did not see that. I'll have to go back and research that.
60 watt hours. Huh?
Or Mike, you guys going to show us something?
Well, I also decided to use battery packs that people in film use for their medium-sized camera rigs. And so I decided I like this format of camera, and it has a V-mount, so it attaches easily and has good contacts on the back here. And so I'm going to be able to put this on there and run it.
Yeah, cool.
And give it weight for the wheels, since my robot's so.
Yeah, and the thing you have to, Mike, when you're doing stuff like that, one of the things you might have to watch, I'm not saying you do, just because potential pitfall is the amount of C's that it can, what its C rating is. Like those might be rated at 1C, which, I don't know what's the voltage on them?
It's 14.4, and it can put out like 10 amps peak. So
continuous. Okay. All right. Well, that's probably good for most of our robots.
Yeah,
but I'm just saying, the reason why a lot of us use lipos is because they have a high C rating. Not that we're really taxing it, but if you use like what is it, 1650? What are those? Paul? What are those?
18650s.
Yeah, the 18650s. You know, they have like 2 amp hours, but they can only pull out about 2 amps. So
Actually, I was just doing research on that. They have some up to 20 amps now.
Oh, really?
18. Yeah. So you have to be careful because I was thinking they were all the same. They're not.
Yeah.
They have different C ratings, and I was surprised there's this much variation in the 18650s. But
Yeah.
and so yeah. So.
But I'm just saying, if you got to kind of match your battery to your
chargings,
to your stuff.
So I had to make sure that it could put out 10 amps, so I can power the wheels, surges, and the camera, and the Raspberry Pi, and
So Mike, can you put a link or the name for that? That's interesting. I don't remember anybody
nice
looking
format. Yeah. How heavy is it, Mike?
Pardon?
How much does it weigh?
Huh?
Oh, did you put a link in?
There's a camera pack, right? For a camera?
Yeah.
Yeah.
Video
It's
camera?
60 watt hour camera pack. It's about the lowest you can get.
Yeah. Can you put a link?
Yeah, I'm not sure what the weight is, but it's not too heavy.
Yeah.
It's not too light. So. Right.
It probably has the 18650s in it. I bet.
Probably.
Yeah.
Yeah, lithium ion.
Yeah, it sounds like what would that be, a 4-cell? 14 volts?
Yeah.
Yeah. Did you say how much it costs?
It was like $50.
Oh, okay.
So
Yeah.
and it's like I said, 4.2 amp hours, 60 watt hours. So.
But what's the name of it? Where can we find one? Look it up.
Yeah, I'm trying to locate it.
Oh, you're still okay. You're on it. We keep throwing questions at you.
Where is it?
Hey, whenever we're ready, I can distract us with some. If you haven't seen the latest Disney video with robots.
Okay, let's see it, Harold.
Okay, so pin me up.
One more thing I
these
wanted to say.
dancing robots or something.
Okay. Go ahead, Mike.
Synchronized dancing robots.
I am going to win the indoor contest next year.
You are
Going down the gauntlet.
Okay.
Oh no! I think that was a mitten. That sounded like a mitten. That didn't sound like a gauntlet to me. I'm just,
Okay. Well, we'll see. Be interesting. Okay. I'm pinning you, Harold.
Pin me up. This was walking around Galaxy's Edge, and I'm going to kill the volume on these things. Well, I'll stick it off. I don't think you can go hit the volume anyway.
Today we're playtesting our new legged walking character platform at Disneyland Star Wars Galaxy's Edge.
I'm going to scoot around to the fun parts. We don't need them talking so much. So these are autonomous. Well, sort of autonomous. I'm sure somebody's driving them. But all their stances, all their movements and stuff, kind of work in an autonomous type fashion, keeping themselves balanced. And it's got some training videos in here. And one of them is like really cool. A couple of examples are like pretty cool. And so I don't know. That looks like RViz to me, but that's just me.
Yeah.
I don't think so.
And so they're introducing these characters. So here you go. I remember Carl running over a popsicle stick on a line follower and he couldn't hang it. These guys, look at this, slipping down a slide of a slope on open ground, and they didn't fall.
It's putting the popsicle stick to shame, isn't it?
Yeah, it is.
Yeah, it is.
You can probably do 4.
While I'm doing that, so if you want to review this all on your own, let me copy the link.
They're using dynamic balancing, which is pretty cool.
Yeah, they got, when you don't have anything to do but build cool stuff, and people give you a budget to build cool stuff, guess what? You get to do cool stuff.
I like it.
And so if you'll watch some of these, you'll see their heads bob. And I don't know if that's because it's slinging weight to keep balance, or they've got some behavior animatronics in there, so it makes them look more organic as they're going and doing, like an animator would do, like see the head shake and all that kind of stuff. I don't know if that's a thing somebody told it to do or something it would just do on its own by just standing there. Anyway, the link is in the chat if you want to go see it. I thought it's really, really cool.
Yeah.
No wonder Disney costs so much to go to.
Yeah, go.
Hey, if we're shifting gears, I got a question for Ray. So we were talking at Rubberama about your mower and how well it mowed, and you were saying that it seemed to run in pretty straight lines, backwards and forwards. And so I just wondered if you could talk a little more about its capabilities and like whether it left strips, whether it wandered enough, whether you could like run parallel, mow on parallel strips, and whether it left gaps between the strips or.
Yeah, I had a video. I still don't know if I have it on this laptop or not. I may have gotten rid of it. It showed it going back and forth. I had it do, I think it was, I want to say it was like 3 meters forward, rotate on one wheel, 3 meters back, rotate, and then, just keep doing that pattern over and over again. I haven't really tested it over longer distances to see if it would, start to leave strips or something. But for the shorter distances, it seemed to be fine. It seemed to stay, in line with the initial pass. In other words, they didn't get successively worse or anything, or,
it didn't drift in angle or in hand.
Yeah, like trapezoidally, it didn't, the runs weren't, skewed from beginning to end, which would leave a strip, of unmowed grass. So.
And were you using waypoint navigation or just heading?
Just odometry and the B&O 055.
Okay.
So I had wheelchair motors with encoders on them.
Okay.
And it seemed to do pretty good. And not, that was the thing of, if I had to set up GPS RTK out here, well, I've already spent the money on it, but I think the two setups, and I got the 8 modules, not the 9, and I think there's even a 10 out now. But those were, I think, like $275 each. I did get the, and I was using LoRa, but I did get the select telemetry radios that SparkFun actually recommended using to, transmit the correction data from the base to the rover. So these are, I want to say, I don't know if these are the 1 watt ones. Yeah, these are the 500 milliwatt ones. So they'll go quite a bit further than the 1/10 of a watt ones. But I haven't tried that out yet to see how well
I
it
think
would
you
work.
answered my question when you said you hadn't done long runs on it. And really what I was seeking to understand is if you used waypoint navigation, it seemed to me that the traditional approach to waypoint navigation can can veer off the path owing to going over bumps and whatever. And I'm reading it, and something that they used on the trucks, and I got to wondering about was pure pursuit as a path following algorithm, as opposed to heading directly for the waypoint, which is our usual cone finding kind of algorithm.
I don't think I understood. What did you have a question about using that versus what I was doing, or?
I was just commenting that it was something I was contemplating, was the use of a pure pursuit path following algorithm, which seeks to minimize the lateral offset from a path between some number of points, versus heading directly towards a goal point, which is what the navigation algorithm that David Anderson has published, and that certainly I used on the Roborama contest. Just wondering if anyone messed with pure pursuit as a path following algorithm.
Yeah, I had a question about that. Do you and I was kind of surprised that Scott did this. Scott has he picks one waypoint that is the wherever he wants to go to at the cone, and he apparently doesn't update it. And I was surprised. I update mine every second. So each it moves, and then 1 second later it basically recalculates the distance and the angle to that whatever that waypoint is. Do you do that as well, or do you have just one waypoint?
10 times a second I recalculate the heading and that I should be on but obviously that allows the robot to wander and still find its way to the cone. When you say Scott doesn't recalculate, what does he not recalculate?
Apparently he doesn't, he at least that's what he said anyway. He doesn't recalculate every, at regular intervals, a second or 10 times a second. He picks one waypoint, and it's kind of a point and shoot, apparently.
Is it the vector he doesn't? Is it the vector he doesn't update, or the waypoint? So your you have your waypoint, which is probably fixed, but your vector to that waypoint does update relative to your movement.
Say that again. It doesn't what?
Your vector to your waypoint does change as you move.
Right, because it's not perfectly tracking where it needs to go, and it's running over.
Yeah, maybe Scott's doing that because he does really well with his odometry. I mean, we've seen that in a lot of ways. Maybe he has such confidence in his odometry and how he's got it for compensation for all kind of variables that he says, "This is what I'm going to do." Maybe, I don't know. I don't really know. I do know he does odometry. He knows he knows how that game is played.
Yep. I saw. Okay, so on the two different, my mower and my other. Well, actually, the mower, it's not heading towards a waypoint. It's just trying to maintain a compass heading, and it does that for a distance. So, and it does it more like 20 times a second because it's reading the odometry in the control loop, which is 50 milliseconds or 20 times a second. So,
okay. Thanks, Ray. I just wanted to get a deeper understanding of your results and the methods behind them.
Yeah, and even the compass headings, I think you can go to like a 1/10 of a degree. I'm just using whole degrees. You know, it's not. I could probably have better resolution on it. I don't know if that would produce better results or not. It may. Who knows? It may screw it up. Maybe 1 degree is fine. You know, for something that goes over the rough terrain that is my lawn. So, but yeah, it seemed to work really well. And I did another one. I actually had a push mower, and I did kind of that repeating pattern in my garage. I just stuck a pin on the back of one wheel, and it marked on my garage floor where, you know, what path it took, and they all seemed to line up. And, you know, even though, you know, that wasn't a perfectly clean surface without little rocks and other stuff on it, and so it seemed to work fairly well.
Oh.
So I'll have to check it out for longer distances to see if I do get the gaps. But right now the deck sticks out a little bit beyond the wheels, maybe, now if I had a rough guess, maybe 6 inches on either side. And the path for the wheels overlapped. In other words, when I went forward and did a 180 degree turn, the one wheel was still where it was. So there's going to be, you know, I'm not making very good use out of the cut width because I'm overlapping at least 6 inches on either side. So, you know, if it's got a little deviation in the line, I still got 6 inches to.
But with a robotic mower, you sort of don't care very much how long it takes. And a little inefficiency on the mowing width, I think, is more than compensated by the fact that it's doing it itself.
Yeah. And I broke down and bought a zero turn this summer, and even that's kind of hard to judge, you know, exactly where it's being cut, because it's a little easier on the left side, but on the right side there's a pretty big chute, and you know, I can kind of guess where the end of the tip of the blade is, but still, you don't want to do that either. You know, you don't want it so close that you're leaving strips that don't get mowed. So you have to, you know, overlap of some kind. So that thing has a 4 foot cut width, so I can afford to waste a little cut width on the. Anyway,
I love robot mowers. I'd love to hear more about your progress and as you make it on that thing.
Yeah, I'll have to see if I can find that video. I think I may still have it on my laptop, but I'd have to look around.
Thanks.
Sure. In fact, maybe I'll look now. Yeah, it'd take me a while to find it. I'm not certain where they are.
Yeah. Maybe next week.
Yeah.
Well, did we run out of discussion?
I have totally lost track of what the queue was. Should I assume that we've run through the queue and open mic and then some?
Yep. Yeah, we have.
Okay. Well, good deal. Well, I think at least I'm interested in following up with Mike on his mitten gauntlet quest for the contest. I want to see how this new style battery works out. It's pretty cool.
Yep.
So, and everything else, of course, too, not to mention the 3D printing and everything. So, and Ross.
Okay, I have
Well, cool.
Alrighty.
Yeah, it's pretty scary.
Well, if there's nothing else, then I think I heard a move to adjourn. So,
Second.
All right. See you
second,
guys.
third, guys, have a good week. Take care. Talk to y'all later.
Okay.
Bye.
Bye.
Bye for now.